Hi everybody, I'm Greg Fishel and welcome to the bonus weather video for this Friday, November 29th. This is the third one of the week, and this is not going to be the most exciting bonus weather video from a graphic standpoint, okay? This is mainly text information, but I will try to elaborate on it as we go through point by point and try to make it a little bit more interesting than just those characters up there. So let me go on ahead and put myself down here in the corner. And here are some facts that you may or may not find interesting, if not paradoxical. The summer solstice this year occurred on June 20th at 3:51 p.m. Eastern Standard Time, okay? Obviously, we're in daylight saving time then, but I wanted to compare apples to apples as we talked about the winter season as well. So 3:51 p.m. Eastern Standard Time, that is when the sun reached its farthest north point in the northern hemisphere, about 23.5 degrees north of the equator. Again, it never quite gets overhead here in the triangle area. We're at about 35, 36 degrees north latitude, but it gets within about 12 degrees of being directly overhead. Okay, and then the Earth was farthest away from the sun on July 5th at 1:06 a.m. Eastern Standard Time. That's right, it was farthest away in the middle of summer, and we call that aphelion, okay? That's the scientific term for that. Then the winter solstice coming up will occur on December 21st at 4:20 a.m. This is when the sun will reach its farthest south point in the southern hemisphere. So it's 23.5 degrees south of the equator, or will be, so you have to take that number, say 23.5, add it to the latitude of Raleigh, which is about 36. And so 36 plus 23.5 is 59.5, okay? And you take that from 90, which is directly overhead, and you get about 31 degrees above the horizon. So instead of being within 12 degrees of being directly overhead, now it's 59 degrees from being directly overhead, much, much lower in the sky. And Earth will be closest to the sun, that's right, on January 4th of 2025 at 8:28 a.m. Eastern Standard Time, and we call that perihelion. That's the scientific or astronomic term for that. Now, climatological summer and climatological winter. We've talked some about this. Climatological summer is defined as the months of June, July, and August, about 3 weeks earlier than the calendar says, or what the astronomical calendar says. And climatological winter is defined as the months of December, January, and February. Again, about 3 weeks ahead of the calendar, okay? So why is that? Well, if you look at the normals based on a 30-year average from 1991 to 2020, the two coldest days turn out to be January 14th and 15th, okay? Right in the middle of January, which is right in the middle of the months of December, January, and February, okay? So that would explain why, from a climatological standpoint, the winter months are defined as December, January, and February. That doesn't mean it can't snow in March. We know for a fact that it can do that, and it can do it big time like it did in 1980. But that's why the climate records are defined that way. And then using the same standard, the two warmest days are July 18th and 19th, which is virtually in the middle, almost, of the months of June, July, and August. And so as a result, the climatological summer is defined as the months of June, July, and August. Now, the shortest day of the year on average is not the coldest day of the year, because the Earth is still radiating more energy to space than it's bringing in from the sun. And that's the case until about mid-January. And then at that point, there's more energy coming in than there is going out, and the normal temperatures begin to rise. By the same token, the longest day of the year is not the warmest day of the year, at least not most of the time, because the Earth is still receiving more energy from the sun than it's losing to space until mid-July. And then after the middle of July, then we're losing more than we have coming in, and so the normals start to go down. Now again, that doesn't mean that you can't have heat waves in August and September. Again, from an historical perspective, we know that can happen. But on average, if you look at the long term, the hottest weather occurs in the middle of July and the coldest weather in the middle of January, despite the fact that we're closer to the sun in January than we are in the summer. And that all has to do with the directness of the sun's rays. When it's 78 degrees overhead, or only 12 degrees from being, or 78 degrees above the horizon, only 12 degrees from being directly overhead. That's a very direct shot, okay? So that's what makes it hot in the summertime. And then in the winter, it's coming in at a very, very shallow angle, and as a result, we're a whole lot colder because of that. The distance between us and the sun varies by about 3 million miles, but that distance is negligible compared to the angle at which the sun's rays are hitting the Earth. Okay, that's it for now. I know that was a lot of numbers and words and very little pictures. In fact, no pictures, but I hope you found that interesting nonetheless. Okay, folks, you have a great weekend, and we'll talk to you again on Monday. See you later.